So welcome to our laboratory here at San Diego State University. The technical name of this place is the Hammer Lab. It's a pretty cool name, H-A-M-R. That's Historical Archaeology and Maya Research Laboratory. So I'm Seth, and I am an archaeologist. And what that means is that I study the human past through artifacts. It's really interesting because archaeology is a huge field. It has great time depth. It goes all over the world, and it all hinges on how you define what an artifact is. Now, an artifact, those are the things that we excavate with our little shovels, our little trowels. This is the most important thing to being an archaeologist. You may think it's the cowboy hat. That is helpful. You don't need a bullwhip, but you do need one of these little shovels to find artifacts, and artifacts are human-modified materials. So anything that people have transformed in any sort of way of life, archaeologists dig up and then try and make sense of those people by reasoning what happened, why it happened, how it happened, and maybe even trying to get into the minds of those people. Now, what's interesting is you may have a question about what's an artifact and what's not an artifact. We know that a lot of the bits of glass and metal, those are easy artifacts. Everybody thinks of those. But we can broaden our definition pretty widely. Think about the number one artifact for each person, and that is you. That's your body, and that's your skeleton. Now, what's interesting is through the course of your life, you make an impact on your skeleton. This is not the prettiest thing to show, but one of my front teeth is a little yellow, and that's a skateboarding accident when I was a kid. And that had an impact on my skeleton. So long after I'm dead and in the ground, if an archaeologist digs me up, they would be able to find that tooth and see that activity, that trauma that gives you insight into who I was and what I did. Now, it's interesting because when we're digging, the first question we always get is have you found any dinosaurs? We don't look for dinosaurs because we're looking for activity of the human past. However, there are dinosaur tracks on this campus that we were able to find. They were in a stone that was actually put into one of the courtyards. So in that way, we do find some dinosaurs. People ask if we found gold. Well, if people of the past had gold with them and lost it, well, then that counts as well. Now, artifacts can be a tricky thing, and I'll give you an example of this. So I have a little bottle here, and if you look very closely, on the side of it, it's embossed with lettering that says Murine Eye Remedy, Chicago, Illinois. So we found this bottle up at the Nathan Harrison site. So Harrison's a very important individual in San Diego history. The first permanent African American and the first African American homesteader in San Diego County. An amazing story, and an individual who was born into slavery, brought west during the gold rush, survived slavery, survived gold rush, survived the Wild West, and ended up living into his late 80s and becoming a local legend. So we found this bottle at his site. We've been digging a lot at the Harrison site. And on the one hand, it looks really straightforward. Marine Eye Remedy was a company that made a little tonic for your eyes when they got dried out. If you go up to Palomar Mountain and see us digging on the site, you'll notice it's dry and dusty and your eyes will get a little dried out. And so when we found this, we looked at the seam on the bottle and we knew when it dated to, and we knew a history of the company, and so it seemed to be very logical, except when you dig deeper. And this is what's so fun about archaeology, is we get to be very skeptical of what the written record says, what the given stories are, and we get to go a little deeper. And when you study the Marine Eye Remedy Company, what you realize is that it was all a hoax. It was all fake. Marine Eye Remedy produced a product that wasn't good for your eyes at all. It had water and borax. Borax is terrible for your eyes. Secondly, this company came up with a fake degree that you could get in college to study for their project. Wasn't real at all. They had this massive ad campaign that was totally false. This is part of what we call a snake oil product or snake oil salesman of the late 1800s. And this is where archaeology ends up telling us a deeper story, because on the one hand, we have this bottle that Harrison used, but on the other, we see this is a time period where you could get away with just about anything in terms of making a product and falsely marketing to people. And this is what people talk about the Gilded Age, talk about snake oil salesmen taking advantage of each other. This is all embodied in just this one little artifact. At the Harrison site, we found over 50,000 artifacts, and we have a great new exhibit at the San Diego History Center that shows a lot of them off. Today we're going to take you on a little journey around our lab and around our campus into this excitement of historical archaeology, what we truly believe is the most fun that you can have when doing research. At this point, I'd like to hand it over to one of my graduate students, Jamie Bastidi, who's going to talk to you more about archaeology and how we go about dating these individual finds. Jamie?
Hi, everybody. So I'm going to, as Dr. Melio said, talk about how we get some of the information about these artifacts. So we do use, as historical archaeologists, we use primary sources like newspapers and diaries, but those kind of give you an idea of like the bigger events. The artifacts can let us know more information about a person's daily life, what jobs they did, what they like to eat, what kind of clothes they wear. So one of the methods that we use is called cross-mending. And we usually do this with like pottery and glass, and it's like a puzzle. We get to glue the pieces together, but unfortunately we usually don't find all the pieces. However, it can help us find information through like patterns with this flow glue plate, or who made an item, like this ironstone bowl, the maker's mark. So that's really helpful. And we also sometimes get really lucky and find cans with labels on it, like this. This is a tobacco can for pipe smoking. Or when we cross-mend glass or ceramic, we have this embossing it's like raised letters on here, and it can tell us when it was made or who made it as well. So that makes it much easier to find out information about some of these artifacts. However, a lot of times that doesn't happen. So we have to find other ways to at least get a date to help get more information about the person that we're studying. So that's when it comes to seriation, which is just tracking changes over time. So anything you can think of can be seriated and changes over time. We have cell phones, cars, computers, even the Joker has changed over time since he was first drawn in 1940. So taking those changes, we can create a graph that is called a battleship diagram that actually tracks how often people use it and how popular it is. So if you think about the iPhone 1, 2, 3, and 4, the iPhone 1 comes out, it gets really popular, and then it kind of dwindles off of interest from people. But then the iPhone 2 comes out, same thing happens. So this can be used for any kind of artifact, anything that you own right now. So we can use diagnostics or clues from artifacts that we don't have any other information on, and get a date by using this technique. So for this can, we use the shape, the size, and then we use this really good clue or diagnostic trait of the lid in order to figure out that this was actually a corned beef can, and it's from 1895 to 1911. So using all these techniques, we can actually create a timeline. So this is for the Nathan Harrison site. All these artifacts are from there, and we found by using cross-mending and using the seriation techniques that the beginning of occupation of the site when he first lived there is 1865. Then all through time we can see that he ate sardine cans, or he ate sardines, he ate corned beef, he had jelly and grape juice. And our last artifact is definitively at 1916, which are a couple coins. They have the date on them. They're pretty easy to research. But this is how we can understand how people lived daily. And that's my favorite part of the archaeology, is finding out this about the person, about the individual. But it doesn't stop there. After we research the artifacts, there's a whole other side to archaeology that's to do with conservation and keeping the artifacts so we can keep researching them later, which is what Natalia is going to talk about for you next.
Thanks, Jamie. She's totally right. When we dig this stuff up, it doesn't look like this. This has all been cleaned up and glued back together. Usually when we first find stuff, you'll get to see the metal especially looks a little bit like fried chicken in the ground. And it takes a lot to clean it up and to get all the rust off of it. And so the next person you're going to meet is Natalia Galliana, and she specializes in conservation of our artifacts. especially those iron objects. Natalia?
Hello everyone, my name is Natalia Galliana. I'm a current grad student here at San Diego State, and I also work for the California Department of Transportation as an archaeologist. Today I'm going to talk to you a bit of conservation and why it's important in our field. So if you can come over a little bit closer, I can show you a bit of the bits that we have. So as Dr. Malio stated, it looks like fried chicken, right? So the first step we do is we bring them to the lab and we clean them. Some artifacts really just take a little bit of water and you can see everything, but artifacts like metal require us to really look into their condition because they've been underground and now they're exposed to the air, which if you know how, so it's called corrosion, which it's kind of the decaying or the falling apart of certain materials. So when they're introduced, if they were in in a damp soil and they're introduced to air, then it's gonna make it go quicker in falling apart. So one of the steps we do is curation, and curation involves different techniques and chemistry. And depending on the condition of the artifact, we can use electrolysis, or our main equipment that we have here is air abrasion. So air abrasion is really a fancy term for a sandblaster. And what this does is it shoots out sand that's actually finer than beach sand. So it helps lift up the rust and then kick it off. So that way we can kind of slow down, kind of get rid of what the rust that's already on there and get rid of it. And that way, it'll take more time for the rust to come back, because once rust starts, you can never get rid of it, but we can slow it down to pretty stable lifetime, I would say. So let me show you how to use this equipment. So here we have the air, the ventilator, which I'm going to turn on. It's a little bit loud. And also, when you're doing science experiments, remember you have to wear your PPE, or your personal protective equipment. So I'll show you all of that right now. Alright. Mask on. Alright, so we have the pedal here and it's going to shoot out some sand. Alright, and as you can see, I'm going to start lifting up. I don't know if you can see the rust coming off. So that's one way we get rid of the rust, by just lifting. But you also have to kind of be careful because it is shooting at a high rate, but you can actually kind of damage a little bit of the artifact, so you want to be careful. And there's also different pressures, different nozzles for different funky artifacts that come out of the ground. So it's pretty cool. Sometimes some rust is really hard to get rid of, so you have to use different levels of pressure.
Hey, I have a question. Can you guys hear me out there?
So as you can see, it can take time for us to work on this and get rid of it. So that's just something it comes in handy, but it does take time. So, it's pretty satisfying too. And then, so one way that we use this for our research is, let me put this on. So again, we want to preserve the artifacts so we can come back later on and do cool stuff with it. So if we didn't we didn't take care of them and they fell apart, because of technology advancing so quickly and this cool chemistry and physics equipment that we can acquire now, we wouldn't be able to test some of these cool artifacts. For example, we had these tins that came out from the site and they were rusted shut. So one way that we were able to open them was through air abrasion. And inside, we were really curious to see what was in there and if there was anything, really. So we were able to find, or actually see, that there's plenty of material in there. And this, because we have part of the label, we were able to decipher what medicine it was and what company.
Natalia, can you hear me?
And this was originally a salve or a lotion that you would apply to blisters or your feet when you had calluses. And we were able to do this by testing it with mass spectrometry or spectroscopy, which essentially is different items have different wavelengths of light, and that can really tell you what is inside. And then another one that we found was this blue powdery substance. So we were able to test this as well. So yeah, it's really cool to be able to combine, archaeology with all these other sciences. It's important to kind of bring in different fields into archaeology. Usually we think of it as just like history and documents, but you can do so much more with, involving all these different fields and really get creative with what you want to do. So that's essentially what we've been doing here, and mainly focusing a little bit on metals, but we do have different types of materials that we're researching and trying to maintain their life expectancy. So yeah, that's what I do here.
I think we have a question. Mike, was there a question?
I have a question. Hang on one second. Let me bring me up. Gene, we're back.
Oh, right.
So Natalia, sorry, I'm eating my lunch. When you're doing the air abrasion, how do you destroy the stuff, or how do you get rid of the stuff that you want to get rid of and not eat into what it is? And does it depend based on what material it is, like how you do it, or what you use to abrade it?
So we get rid of it by, so there's this, so Big Blue here, this is a ventilation system, and it's also like a vacuum, and through back here there's air, like that little hole back there. Let me show you. Oops, sorry. Yeah, there's a tube that kind of sucks in all the rust into that little hole right there.
Yeah.
And that's pretty much where it all goes. And later on we find a way to dispose of it, but it takes a while for it to fill up. As you can see, it's a very slow process, so it's going to take time for it to fill up. So that's how we get rid of the rust.
And it doesn't harm the object?
Other ways we could do that? Oh, sorry?
It doesn't harm the object? You just eat away at the rust?
It can harm the object sometimes, especially if it's already it's a thin metal or it's very delicate. So that's why you have to, understand the air pressure that's coming out of the machine. And there's also different types of sand that we use. So the more robust kind of rust that's on certain artifacts, we use like the bigger particles to take it off. But then when it's like a dainty little artifact, we want to use something that's softer and a little bit more precise with the nozzles. So that's one way we can ensure that we take care of the object as well.
Gene and I were just talking, is it like different kinds of sandpaper, different grits of sandpaper?
So yeah, it's different. It's actually it's just sand. So it's like a powder. So it's sand, but it's finer than beach sand. And it actually shoots one particle of sand at a time, which is crazy because it really feels like it's shooting a lot, but it's one at a time, and it just kicks off the rust. So it's pretty cool to see.
It's amazing that it can just get one particle at a time. Did you hear that, Mike?
Yeah, totally.
The machine pulls one particle at a time to best preserve those artifacts and get the most out of it. That is crazy technology.
It really is.
That is crazy.
Natalia, this is my last thing. Can you show me I think it was the salve, the little tiny thing that had the half of the label on it that was as big as a quarter, and you guys were able to determine what it was. Can you show me the label one more time? And then that's my favorite. It's my favorite.
I mean, he's
Nick
geeking
Harrison
out.
side
Look.
story. I'm totally geeking out.
Sure. Here it is. This is the Kohler's One Night Corn Salve, which again is a lotion for the feet and calluses or blisters. And this was actually inside of it. So
The most amazing part to me, and
so it's
I hate to
usually-
miss the point, but the label. Can I see the label on the front of it?
oh yeah,
And
of course.
So you guys were able to determine what that was by having, by looking, by reading whatever remains on that label, whatever words are there. You guys figured out what it was and who sold it. Is that right?
Yes, that's correct.
That's amazing.
Doing some deep research
Look at,
and
we just blew Gene's
That's
mind.
like that. Wait, hold on. That like CSI. What?
Yeah.
Is that where you're at?
Yeah.
Is that where you're at, Mike?
It-
You
it-
CSI? I'm there with you, man.
Yeah, it's one of my favorite sort of Nate Harrison side
I
stories.
feel it.
Because, yeah.
I feel it.
Well, cool.
Thank you so much.
Is
was
that all we got
amazing.
from you guys this time around? Because we're going to talk to you guys in a little bit again, right?
yeah, that's what we have for now.
Perfect.
We'll have more surprises later.
Totally cool. We can't wait to come back to you guys in a little bit. Thank you guys, and we'll see you in a little bit.